Hello students, welcome to class 11 physics. In this video we are going to discuss about the dynamic friction as well as the rolling friction. First of all, let us see the dynamic friction. Explain dynamic friction, write laws of kinetic friction, define coefficient of kinetic friction. We had already discussed about the static friction, that the frictional force that opposes the external force to keep the object stationary is called as the friction, and the frictional force, the maximum frictional force beyond which the object comes into motion, is called as the static frictional force. Here, when magnitude of force acting on object lying on the surface exceeds the maximum static friction, the object will start moving in direction of the external force. Hence, value of frictional force will reduce less than maximum static frictional force. That means here you can see the object is lying on the surface and the external forces provided to the object in this direction. Then the surface will be providing the friction to the object and it will be opposing the external force to keep the object stationary. Now see, if the frictional force is such that it can keep the object stationary, that frictional force is called as the static frictional force. And the maximum frictional force that does not allow the object to move, the maximum force that is provided against the external force to keep the object stationary, that is called as static frictional force. But if the static frictional force is less compared to the external force, then the object tends to move. That means these type of frictional force which is applied by the surface to oppose the external force, but even though the object starts moving, is called as the dynamic frictional force. So here we can say that the frictional force will reduce less than the maximum static frictional force. That means these type of frictional force, that is the kinetic frictional force, is less compared to that of the external force. Frictional force which opposes relative motion between the surfaces in contact is called as the kinetic friction. It is denoted by Fk. Laws of kinetic friction. First, the kinetic friction do not depend on area of contact between the surface. So as we have already seen for the static friction also, whatever type of friction it may be, right? But friction depends on the contact between the surfaces and does not depend on the area of the contact between surface. Kinetic friction force do not depend on relative velocity of the object in the motion. Kinetic friction force is directly proportional to the normal force, that we have seen already for the static frictional force. This frictional force, that is the kinetic frictional force, is also directly proportional to that of the normal force. Removing the proportionality, we keep the proportionality constant, that is mu k, which is equals to coefficient of kinetic friction. So rearranging this equation to get the coefficient of kinetic friction, which is equals to Fk upon n. So we can write the definition of this from the formula itself, that the coefficient of the kinetic friction is equal to the ratio of the kinetic frictional force and the normal force. Here Fs is greater than the Fk. That is, we have already discussed that the static frictional force is greater than the kinetic friction force, because static frictional force is such force that does not allow the object to move, that opposes the external force. So it tends the object to remain stationary, whereas the kinetic frictional force opposes the external force, but it cannot keep the object stationary and it is less compared to that of the external force. So we can say that static frictional force is greater compared to the kinetic frictional force, and hence we can also say that coefficient of the static friction is greater than that of the coefficient of the kinetic friction. Once relative motion starts, then by Newton's second law of motion, acceleration of the object is a equals to f minus fk upon m. These we can write by using the general equation f is equals to ma. Here we can say that f minus fk equals to ma. Here f is the external force, fk is the kinetic frictional force. Because both are in the opposite direction, here we are writing minus sign. So from these equation we get acceleration is equals to f minus fk upon m. If the object move with constant velocity, then f is equals to fk. If the external force applied is reduced to 0, then acceleration of the object will be minus fk by m. Hence, it will stop after covering some distance. That means in this equation, if we take the external force equals to 0, then a equals to 0 minus fk by m. That is equals to minus fk by m. So, what will happen? If the external force is now reduced to 0, then the object will cover some distance with the acceleration minus fk by m, but after some time it will stop. So students, you may note down this theory. Now, let us discuss about the rolling friction. What is rolling friction? Write laws of rolling friction and define coefficient of rolling friction. When body is rolling without sliding, friction force is called rolling friction. It is denoted by Fr. That means, let us consider an example, that is an inclination, and if we put a ball on the top, then instead of sliding, it will be rolling down. That means if it is sliding, then the contact surfaces remain same throughout the path. That means if this is the contact of the ball's surface and the surface on which it is sliding, it remains same throughout the path. That is called as sliding. But here rolling means every portion of this ball, every surface of this ball comes in contact with this path, in contact with this surface. So its contact changes every time. So when the body is rolling without sliding, friction force is called as rolling friction and it is denoted by Fr. Laws of rolling friction. Magnitude of frictional force do not depend on the area of contact. So as we discussed in the static frictional force as well as the kinetic frictional force, that the frictional force do not depend on the area of the contact. It is necessary that to provide the friction by the surface on the object, it should be in contact. But here it does not depend on the area of the contact. Second, the magnitude of rolling friction is proportional to the normal force, same as that of the kinetic friction as well as the static friction. Here it should be Fr. Fr is proportional to N, and so we can say Fr is equals to mu r into N, where mu r is the coefficient of the rolling friction. It is unitless. Why it is unitless? Because see, mu r equals to Fr upon N. Here Fr is the rolling friction, so its unit is Newton. And in the denominator we are having normal force, its unit is also Newton. So this gets cancelled out and it is unitless. So also it is dimensionless. When a ring or a sphere rolling without slipping over a horizontal plane, at every instant there is just one point of contact between the body and the plane, and this point has no motion relative to the plane. So when the object is rolling, it rolls when it is a sphere or it is a ring. Then during the rolling, only one point of the body comes in contact with the plane. In the ideal situation, kinetic or static friction is 0 and body should move with constant velocity. But that is not true. This is just the ideal situation. But in practice, there is some resistance to motion in form of rolling friction, hence motion is retarded. That means if the external force is resisted, then we can say that the motion is retarded. To keep the body rolling, some applied forces needed. That means unless the external force is applied, the body does not keep on rolling. So if we want that the body should roll continuously, then the force should be applied. For object of given mass, rolling friction is 1 by 100 or 1 by 1000 times the static or kinetic friction. That means the rolling friction is less compared to that of the static friction and the kinetic friction. Because of these reasons, discovery of wheel has major milestone in human history. Origin of rolling friction is different than static friction and kinetic friction. During rolling, the surfaces in contact get momentarily deformed a little and small part of body remain in contact with the surface. That we have already discussed, that when a ball is rolling down an inclined plane, then on the point of the ball comes in contact with the surface. As a result, there is component of the contact force parallel to the surface which opposes the motion. That means these frictional force opposes the motion of the object. So when we compare the three types of the friction, that is the static friction, kinetic friction as well as the rolling friction is less compared to that of the kinetic friction, and these kinetic friction is less compared to the static friction. So we can say that the coefficient of the rolling friction is less compared to that of the coefficient of kinetic friction, which is even less compared to that of the coefficient of the static friction. So students, you may note down this theory.